All right, welcome back. Today we are going to dive headfirst into the world of information security. We're going to pull back the curtain and see exactly how huge organizations build their digital fortresses, piece by piece, all the way from the highest level strategy down to a single line of code. So it really all starts with a question just like this. And you might be thinking, that seems like a massive leap, right? Well, believe it or not, there's a surprisingly logical and structured system that connects that one simple rule to the security of an entire company. And in this explainer, we're going to map it all out for you. Okay, let's get into it.
You know, every solid structure needs a master plan. Think about it like a city's building code. Before anyone can even lay a single brick, there are these big overarching rules that make sure everything built is safe, sound, and actually does what it's supposed to do. In the world of InfoSec, this master plan is what we call governance.
And a huge piece of that building code is a global standard called ISO 27001. Now, this isn't just some friendly suggestion, it's a really comprehensive framework. It tells organizations what they need to protect, how to handle risks, and, this is critical, how to keep getting better and better at security over time. It's basically the high-level rulebook for the entire project.
But here's the thing about ISO 27001. It's not just a technical checklist. It's actually a powerful business tool. It forces a company to connect its security plans directly to its business goals. For instance, risk management helps them make smart financial decisions, not just tech decisions. Policies make sure the tech team is building what the business actually needs. And defining roles? That just makes sure everybody knows who's responsible for what. It's all about building security that truly supports the organization.
Okay, so if governance is the city's building code, how do we get to the actual, building? Well, let's zoom into the next level of detail, the architect's blueprints. And this is where we find three absolutely critical types of documents: policies, procedures, and guidelines. Each one has a very specific job to do.
Let's kick this off with a super simple example we can all get our heads around: passwords. The policy is that high-level mandatory rule. Use strong passwords. It's simple, it's clear, and it's not up for debate. The SOP, which stands for Standard Operating Procedure, is the step-by-step instruction manual. Here's exactly how you reset your password. And the guideline? Well, that's just helpful advice, the best practices. Hey, here are some tips on what actually makes a password strong.
And this table here really breaks down the formal differences. A policy states the big picture rules. An SOP gets down into the nitty-gritty details, the real how-to. And a guideline offers up those best practices. But the most crucial point, just look at that last column. Policies and SOPs, they're mandatory. You have to follow them. Guidelines are optional. They're just helpful suggestions to help you do things better.
So let's put this into a real security context. The policy is broad and absolute. Only authorized users can access systems, period. The SOP is the specific process for making that happen, the step-by-step instructions for onboarding a new user. And the guideline? That provides some helpful tips, like how to create a password that actually meets the policy's strength requirement. See how they all snap together and support each other?
Okay, so we've got our building codes, we've got our blueprints. Now it's finally time for construction. In security, we call this the implementation lifecycle. It's the structured, step-by-step process of actually building and putting a security control into action.
And you can see, this is a very deliberate cycle. You don't just flip a switch and, hope for the best. You start by identifying what's most critical to protect. Then you document the exact steps in an SOP. Now, the most critical part is next: testing. You test everything in a safe, separate environment to make sure it works without breaking anything else. Only after a successful test do you deploy it into the live system, where of course it's monitored constantly. And this isn't a one-time thing. It's a continuous loop of improvement and protection.
All right, let's make this even more concrete. We've gone from the big city plan to the blueprints, and now we're going to look at installing one single high-tech lock on the front door. We're zooming way in to look at a few lines of code used to harden a Cisco router, a really critical piece of any network.
So the first principle of our high-tech lock is pretty simple. If you don't need a door, don't have one. In networking, this just means turning off any services that aren't being used. Every single active service is a potential way in for an attacker, so we want to reduce what's called the attack surface. Fewer doors means fewer opportunities for a break-in.
Putting that principle into practice looks like this. An engineer just types no CDP run. What this command does is disable the Cisco discovery protocol.
It's a feature that helps network devices find each other automatically. If you don't need it, turning it off closes a potential door for attackers. It's a tiny, simple action that directly enforces a high-level security principle.
Next up, we need a secure way to manage this router from somewhere else. Now, the old way was a thing called Telnet, which sent everything, including your passwords, in plain text. Yikes. The modern, secure way is SSH, or Secure Shell, which encrypts the entire conversation. It's basically the difference between sending a postcard and sending an armored car. And the line of code to enforce this is just beautifully simple. Transport input SSH. That tells the router to reject any of those postcards and only accept the armored cars. In other words, only communicate using secure SSH. That one little command makes a massive difference.
Okay, but what happens if someone forgets to log out? Or what if a hacker is trying to guess the password over and over and over again? Well, this is where timeouts and lockouts come in. One automatically logs a user out after they've been inactive for a while, and the other locks an account after too many failed login attempts, stopping those brute force attacks dead in their tracks.
And the practical implementation is a command just like this: XX timeout 50. That 50 simply means 5 minutes and 0 seconds. It tells the router, hey, if someone's session has been idle for just 5 minutes, log them out automatically. It's another simple and really effective way to enforce the policy.
So, we've gone from the 30,000-foot view of governance all the way down to a single specific command. Let's zoom back out and tie it all together with a quick summary of the key takeaways here.
Just remember this: a policy is the rule, and SOP is the step-by-step guide on how you follow that rule. A guideline gives you tips to do it even better. And the big one, ISO 27001, is that master plan that helps govern the whole system, secure the company's assets, and make sure IT is aligned with what the business actually needs.
You know, this entire structure gives an organization incredible control and a really clear path to being secure. The policies are written, the procedures are all documented, the code is implemented. It's perfect on paper. But that brings us to our final question. What do you think is the single biggest challenge in making a perfect system like this actually work with imperfect, real people every single day?